Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rasyid bin Abdul Rashid. So today I'm gonna present my answer as a question given in the assignment in the video presentation for ELE 242. So this is the question 1. So figure Q1 show a subtractor circuit. Assuming the op-amp is ideal, determine the output voltage for this circuit. So how we gonna do? Okay. So for this question, in order to find the voltage output, we have to find the voltage minus first. So to find that, we have to apply Thevenin circuit for find the VTH. So V plus is equal to 1K over 1K plus 2K times with 9, which is our voltage supply. So we get the 3 volt. So since the voltage plus V plus is equal to V minus, which is 3 volt, so we just substituting the value of V minus into this formula. So as you can see here, 10 minus V minus over 1K equal to V minus minus V output over 1K, which is this is actually is current in is equal to current out. So we just substituting the value of V minus into the formula. So 10 minus 3 over 1K equal to 3 minus V output over 1K. So we get the value of voltage output is negative 4 volt.
Alright, so this is the answer for the question 1 for the simulation. So the purpose of doing this simulation is to determine whether the answer from the calculation or the theory method is same or equal with the simulation. So this is the circuit that has been configured in the Proteus. So we have 4 resistor and 1 op-amp. That is IC 741 as function as the op-amp. Alright, and we have 2 voltage DC supply which have been setting up with the value of 10 volt. Alright, 10 volt for the voltage 1 and the voltage 2 is 9 volt. Alright, so let us simulate, and as you can see there, we get the value of negative 4.01 volt. Therefore, it means that the value of voltage output gain from the simulation is same or equal with the calculation method. Alright, even though there is 0.01 different, that is discrepancy as we use the component in the simulation. Okay, that we can neglect it. So, hence the result is acceptable.
Alright, this is question 2. Okay, question figure Q2 shows a combination of 2 operational amplifier circuit. Determine the output voltage of VO1 and VO2. Assume all op-amp are ideal. Alright. So, in my answer, so in order to find the VO1, we have to find the value of V minus and V plus first. Okay, so how? So as you can see here in the circuit, we have to apply Thevenin analysis to find the V plus here, as there is 2 resistor in the circuit, okay, in the line. So V plus is equal to 18K over 18K plus 30K times with 3 volt, which is our voltage supply for this line. Therefore, we get the value of voltage plus is equal to 1.125 volt. So, since the value of V plus is equal to V minus, which is the 1.125 volt, therefore we can just substitute the value of V minus in the formula. So this is the formula. So 5 minus V minus over 120K is equal to V minus minus V out 1 over 300K. Therefore, we get the value of negative 8.56 volt for the V out 1. Okay, next question is to find the V out 2. Okay, so as you can see here, for this in order to find the V out 2, we have to No, the value of V minus and V plus. So we have to find the V plus. But as you can see in the circuit, there is two resistor here in one line, and there is two voltage supply. Therefore, we have to apply the Thevenin for the VTH for both voltage supply. Okay, so for the first condition, V out 1 is on and the 0.7 volt is off. So V plus 2 is equal to 15k over 15k plus 20k times with its voltage supply, which is negative 8.56 volt, and we get the value of negative 3.67 volt. Okay, so for the second condition, the V out 1 is off and the 0.7 volt is on. Alright, so V plus 2 is equal with 20k over 20k plus 15k times with the voltage supply, which is 0.7, so we get the value of 0.4 volt. Therefore, the both value for V plus 2 will be adding up. Okay, so after we get adding up, the value of V plus 2 is negative 3.27 volt. So after we get the value of V plus, we can find the V output 2. How? Just apply the formula. So 0, okay, where we get the 0? Okay, from this. Okay, this is the ground, so just place the 0. So 0 minus V minus 2 over 27k equal with V minus 2 minus V output 2 over 56k. So just substitute the value of V minus 2 with the negative 3.27, since the value of V minus 2 is equal with the V plus 2. So after we substitute the value, we get the result of V output 2 is equal with negative 10.05 volt.
Alright, so this is the answer for the simulation for the question 2 to determine whether the simulation voltage output is equal with the calculation 1. So okay, so this is the circuit that has been configured. So we are for this question we are using 2 of op-amp, as you can see here, and we are also using 8 of resistors, which are 120k, okay, 30k, 18k, 300k, 20k, 27k, 56k, and 15k. So for the voltage power supply, we are we are setting up by 5 volt, 3 volt, and also 0.7 volt. Alright, so in order to get the answer, we have to simulate it. So after simulate, we can see that the result there is negative 10 volt, which is equal or same with the calculation or theory method. Hence, this result is acceptable.
So this is the question 3. Figure Q3 shows an instrumentation amplifier circuit. Calculate the output voltage. Assume all op-amp are ideal. So as you can see here, in the circuit, we have a voltage follower here. Okay, and this is also voltage follower. Okay, let us figure out the answer. Alright, so in order to find the value of V output here, we have first to identify the value of V output 1 here. Okay, I just label it V output 1 here, and V output 2 is here. So we have to find the value of V output 1. So how? So this is I call this V naught 1. Okay, and this is V naught 2. Alright, so we have to find out the V output 1 by using the value of V naught 1 and the V naught 2. So since this is the voltage follower, therefore the voltage in node 1 is equal with the V minus, which is 10 volt, okay, because V minus is equal with V plus. Same goes to the V note 2, where the value of V minus is equal with the value of V plus, which is positive 5 volt. Okay, so since the V note 1 is 10 volt and the V note 2 is 5 volt, therefore we just applying the formula and substituting all the value in the formula. So V output 1 is minus V note 1 over 1.5k is equal with V note 1 minus V note 2 over 1.2k. So after substituting all the value, we get the value of V output 1 is equal with 16.25k. Alright, so settle for the V output 1. So next we have to find out the value of V output 2 here. Okay, so how? Just applying the formula. So V note 1 is minus with the V note 2 over 1.2k equal to V note 2 minus V output 2 over 1.5k. So after substituting the value of V note 1 and V note 2 in the formula, we get the answer of V output 2 is equal with negative 1.4. Next, we already get the value of V output 1 and V output 2. So in order to find the V output here, we have to determine the value of V plus. Okay, V plus is equal to V minus. So as you can see here, we can find the V note here. Okay, to get the value of V plus. So how? So V plus 3 is equal to V note 3. So I label it, this is V note 3. Okay, so how to find it? Just applying the formula. So V output 2 that we get in the previous step minus with V note 3 over 1k is equal to V note 3 minus 0 over 1.5k. So where is the 0 get it? Okay, so as you can see here, this is ground. So when it's ground, we just put it at 0. Okay, after substituting the value of V output 2 in the formula, so we get the value of V note 3 is negative 0.75 volt. Okay, since the value of V note 3 is equal to V plus, okay, V plus 3, and it is also equal with V minus 3, which is here. So we just using the same value to get the V output. So how? Just using or applying the formula. So V output 1 is minus with the V minus 3 over 18k equal with V minus 3 minus V output over 18k. So after substituting all the value which is in value of V output 1 and the V minus 3, we get the value of V output is equal with negative 17.75. Alright, so this is the answer for the simulation circuit. Alright, so let's. Alright, so next question is question 3. Alright, so next question is question 3. Okay, so we are required to configure the circuit as shown in the figure Q3. So in this question, we are using 3 of op-amp to configure the circuit. This is the IC use 741 function as op-amp for this circuit. So as you can see here, this is a voltage follower. So there is no voltage difference between this point and this point. Same with this line. Okay, so for this circuit, we are delivering the voltage supply of 10 volt. Okay, so this one is 5 volt. Okay, only 2. And then in order to know the result for this voltage output for this circuit, we have to simulate it. So we get the negative 17.6. So therefore the simulating result.
Alright, so as the value of the simulation voltage output is equal with the value of voltage output gain from the calculation, so the result is acceptable. Alright, so this is the last question, which is question 4. So the question is required us to find out the value of V output 1, V output 2, and V output 3. So how do we get that? So that's alright, so this is the question 4. So this is the answer in a theory method or calculation method. So first we have to find the value of V output 1 here. Okay, so how do we find that? So we just applying the current in and current out formula. So first we have to identify the value of V plus. Okay, so as you can see here, the value of V plus is equal to V minus, which is 0 volt as it grounded. Okay, so okay, next we just by applying the current in and current out, you can get the value of V output 1. But then in the in the current inside it, as you can see here, there is 2 resistor and 2 voltage supply. Therefore we have to adding up both current value so that we can get the total value of current in. So by doing that, we just using the formula here. So 4 minus 0, as it the value of V plus is 0, over 2k plus 2 minus 0 over 2k is equal to 0 minus V output 1 over 1.5k. So after substituting all the value in the formula, we can get the result of V output 1 is equal to negative 4.5 volt. Okay, settle for the V output 1. So next, V output 2. So as you can see, this is the V output 1. Okay, as you can see here, V plus 2 is connecting with the V output 2 without any resistor there. So this is the follower voltage. Therefore, there is no voltage difference between this point and this point. Therefore, the value for the V output 2 is equal with the value of V plus 2. Okay, as you know, the value of V plus 2 is equal to V minus 2, and the value of V minus 2 is equal to 2 volt. Okay, as it is connected with the voltage supply 2 volt. Okay, therefore the value of V output 2 is equal with 2 volt. Right, settle for the V output 2. So next, we're gonna find the value of V output 3 here. So how? First, we have to identify the value of V minus 3. So as you can see here, the value of V minus 3 is equal to V plus 3, and it is 0 volt as it is grounded. Okay, so how to find the V output 3? Just by applying the formula of current in and current out. So as you can see here, in the current inside it, we also have 2 resistor and 2 voltage. Okay, as it is supplied for this circuit. Okay, so just by just the previous example, we have to adding up its current to find out the total value of current in. Okay, so by applying this formula, which is V output 1 minus V minus over 1k plus V output 2 minus V minus over 2.4k is equal to V minus V output 3 over 2k. So by just substituting all the value of V output 1, the value of V minus 3, and the V output 2, we can get the result of V output 3 is 7.33 volt. Right? Alright, so this is the answer for the simulation of the circuit, as we wanted to know whether the calculation is correct or not. Alright,
configure the circuit as shown in the figure Q4. So in this circuit, we are using T op amp, okay, as in the circuit. Okay, so we are configuring the resistor by 2k, okay, 2k also, 1.5k, 2.4k, 1k, and 2k. Alright, so for the voltage supply, we are supplying of 4 volt for V1 and 2 volt for V2. So as you can see in the circuit, this is a voltage summing and this is a voltage follower. Alright, so in order to know the voltage output for the simulation, so we have to simulate. So the answer we get is positive 7.33. Therefore, the result from the simulation is acceptable.
Alright, so this is the answer for the simulation for question 4. Alright, as you can see in the circuit, okay, in order to get the voltage output for question 4, we are using 3 of op-amp in the circuit, okay, and we are also applying 6 of resistor in the circuit. Alright, so all the resistor has been setting up with the value of 2 k ohm, okay, 4 k ohm, 1.5 k ohm, 2.4 k ohm, 1 k ohm and 2 k ohm. Right, so for the voltage DC supply, we have been setting up with 4 volt for voltage supply 1 and 2 volt for voltage supply 2. Alright, so as you can see here, this is the voltage follower and this is the voltage summing. Okay, alright, so in order to get the result, we have to simulate it, and as you can see there, the result of the output we get 7.33, which is similar or same with the calculation one. Okay, therefore the result for this question 4 is acceptable. Alright, that's all from me. Thank you.